In this video, we're going to model exponential growth. It says a sample of bacteria experienced 5% daily growth compounded continuously for 14 days. At the end of the 14 days, the sample had reached the size of 80 bacteria. What was the sample size at the beginning of the 14 days? So we need to pull out our exponential growth model, which I want to compare that to our continuously compounded interest model. And you'll notice that they're basically the same equation. You've got P of t, which is just your ending amount, and A for any type of business would be the ending dollar amount. P of 0 is the starting amount, and P, the principal, would be the starting amount. And then you have E to the KT and E to the RT. K and R are both talking about the rate. So this one's the decay and growth rate, and this is the rate of interest, or the which could be positive or negative, which is the same as like the decay and growth rate. So they're the same equation, just with different variables. But we're going to use this equation on the left, the P of t, to model this thing. So we need to write down the things that we know. They say it's a 5% daily growth, so that's going to be a positive 5%. So we're going to say K equals 0.05. They give us a time frame that's 14 days, so we're going to say T equals 14. And maybe put days on there. Sometimes we'll have hours. And it says the sample had reached a size of 80 bacteria. So that's the ending amount, so that's P of t. Is 80 bacteria, which means we don't know P of 0, and that's what we're looking for in the problem. So we start by setting this up and writing 80 equals P of 0, E to the 0.05 times 14. In the calculator, I'm going to plug in E to the 0.05 times 14 gives you 2.0138. I'm rounding that, but I won't round it when I actually divide this. So I'm going to use this number here, even though I have it rounded here for the algebra purposes. We're going to divide by 2.0138 on each side. So P of 0 is going to equal 80 divided by 2.0138. So if I take 80 divided by, I'm going to use the whole number there, second answer, 39.72. But they tell us to round your answer up to the nearest whole number, so that would be 40. So our original bacteria amount was 40.